question, and I will pick anybody randomly to respond to the question. So please, let us pay very close attention to the presentations as they occur from now. So having said that, and if we have all agreed to that approach, I don't know, do we start?
Yes, sir, we can start.
Okay, case one is about hello. Our case
yes, sir,
one.
we are with you, sir.
Our case one is about a vehicular traffic-related gaseous air pollution. Remember, it is vehicular traffic-related gaseous air pollution, and it the location is Makurdi Metropolis in Benue State. That looks at the air monitoring and all that. And you are supposed to respond following these tasks. Give us a design a sampling methodology and an active passive sampling. Just show us what you did, what the one you chose, why you chose it, the area, and what is the preservation processing for the gaseous samples. What are you using to collect your data, and you justify those things. They are all there. So without wasting time, let's call the case study group one as the people presenting the case study one, and I would stop sharing for them to be able to share. If they want to share, I can stop sharing my slide so that they can share their slide if they are able to share.
If they are able to share, yes. We are still coordinating at the group level who is going to come up for the first group.
Okay, so
and the group was actually named Air. So
okay, so group
so
A
please,
should come up.
That group, Mr. Kwashi Julius is there.
Okay.
Mr. Uche, George Okuma.
Okay.
I think Isaiah Teyila, Bridget. I can see a number of yes, sir.
Okay.
Yes, Susan. So please, who is coming up? Mr. Yes, are you the one coming up? Is it Mr. Uche? Is it Mr. Tiohomba? So please, who is coming up quickly?
We are waiting.
Is someone speaking? Mr. Julius, Mr. Yasa, who is stepping up? Mr. Andrew Tepine, yes, I have unmuted you. I'm looking for Mr. Julius. Okay. Susan, I've unmuted you too. You are part of the group. Mr. Julius, I'm looking for you to unmute you too.
Sorry, Mr. Class Rep, we had earlier had an arrangement that Susan and Mr. Kwashi Julius to stand in for us. So except if they are not
standing for awesome.
Yeah.
So they are here already. So maybe Susan goes first before Julius. Hello, Susan, you can unmute yourself. Mr. Julius, are you on the call? I can't get to. I'm looking for you still. Yes, I've seen it. Mr. Julius, please unmute yourself. Also. Aha, you can speak, sir.
Good morning.
Good morning, sir.
Good morning, class.
Good morning.
Good morning, everybody.
Good morning.
Good morning. Susan, are you the one to speak first or?
Hello, class. Please permit me to announce the presence of our HOD. He's on board now, and may we give him some minutes. Let's pause and give him some minutes to address us. HOD and DD, sir, you're welcome to the class, sir.
HOD, sir, you're welcome to the class. Maybe let me look for our HOD and unmute him.
Yes, please go ahead and unmute our HOD, please.
Aha.
All right, good morning, Professor Fegbu and all members of the ENS 2025-2026 Masterclass.
Thank you,
I am
sir.
supposed to be here.
Good morning,
I'm
sir.
supposed to be, thank you. I'm supposed to be here quietly, incognito, but since Prof has exposed me, I will just follow from the background. It's interesting. I want to see the ideas you bring into this STEM paper and then some of the possible actions that we can even implement in the papers you'll be presenting this morning. Thank you very much. I'm just here as a participant in your class session. Over to you, Prof. Thank you, sir.
Thank you very much, Didi, for your time. We know your time is precious. Thank you so much for this. We really appreciate it. Thank you, sir. I'm going to now go on. Presentation continues.
Yes, sir. Mr. Julius, you can continue, sir.
Good morning, class.
Go ahead,
Good morning.
sir.
Just go ahead. They are listening. Go ahead.
We are looking at the vehicular traffic related gaseous air pollutant in Makudi. And first, we are looking at the methodologies involved. And we have to look at the active sampling. The active sampling, that is the high priority we are going to consider. How we can deploy the instrument to get to test for carbon monoxide, nitrogen dioxide, and sulfur dioxide using a calibrated portable analyzer. We are doing that so that we have real-time high temperature resolution data for hotspots identification, like in the Wurukum roundabout there, and also for passive sampling. There's another way of also getting the indicator to test for these gases like the carbon monoxide and then the nitrogen dioxide. That is we get also that is for a traditional method of testing for those things. That requires a laboratory-based test for nitrogen dioxide at the site. That is maybe either Wurukum or maybe the highway roundabout or the Wadata, as the case we are considering. Then the passive method, which is cost-effective for assessing the long-term exposure and validating active measurements. Then we also have to consider the sampling frequency, the time, the duration as well. So both for active and the passive, we consider the time, then the duration and the location for carrying out this. So for monitoring site selection, that is site location, we are considering the Wurukum roundabout, and then the high level roundabout, and then the Wadata. We get those samples using the passive and the active active methods, as I have mentioned, and then we consider this design. Hello.
We are here. We are here. Can your second step in for you? If
Okay, she can come in.
Yes, you can. Go ahead.
Mr.
Okay.
Yasa, can you step in for him briefly?
Good morning, class.
Good morning.
Good morning. Go ahead.
My name is Susan. I'll be stepping in for him
While he clears his throat very well.
while he clears his throat and gets back on track.
Go ahead. Your time is running. Oh.
Yes, our case study, vehicular traffic-related gaseous air pollution in Makurdi. The definition of our problem was to evaluate levels of inorganic gaseous pollutants, such as the CO, NO2, and SO2 at major junctions like Burukum High Level Roundabout. The objective of our study was to determine the concentrations of these gases during peak and off-peak traffic hours. One of our objectives was to compare the record levels with the Nigerian National Ambient Air Quality Standards. Our monitoring design and sample strategy, the metrics is air ambience. One of the sampling this thing we are using is sampling location. We have 4 strategic locations, high traffic junctions such as the Wurukun roundabout, high level and North Bank, and also Wadata Market. And our control site is a residential area like the Benue State University staff quarters. That's our control site. Our sampling technique and equipment that we are using for this research, we are using the active sampling technique using handheld gas monitor. Can you hear me?
We can hear you, ma.
Very well.
Continue.
Go ahead.
Okay. We are using the handheld gas monitor. This equipment is very easy to use and can trap in different gaseous concentration at different level. So how we handle our samples and prevent them from getting contaminated. We read directly from the monitor, but we log the data immediately after monitoring conditions such as temperature, wind speed, and other gases that are also dispatched in that region. But the gases we are testing for are the 3 major gases that are harmful. So part of our analytical techniques and methods selected, our key parameters are carbon monoxide, nitrogen, and sulfur dioxide. Our proposed analytic technique is to use sensing, direct reading for real-time data, and also to use colorimeter. This method using absorption bubbles. The reason we are taking this research is to provide immediate data during traffic surge and portable for field use in Makurdi. And this research we're taking, because it's a first-hand research, it does not require complex laboratory transport for inorganic gas. As we are taking the readings, is giving us a real live reading for the research we are about to take. One of our presentation plan is to have a clean air environment before each field outing. We make sure that all the equipment we are using are not having previous readings, okay? Our visualization tools during this is showing how pollution level rises during the fall of day, morning and afternoon, and even at evening, because during traffic rush in the morning where people are going to work, the traffic pollution around those roundabouts are going to be very high. At noon, we expect that it's going to be low because there will be few people using the road. Evening, we expect high values too. And probably when we cross-check this at night, the pollution should have reduced. So with this in mind, when we are going to the field, we have expectant results of how the readings should be. Okay, can the other person take over now? Is he ready?
Why not go continue, Miss Susan, because your time is almost up. Just continue and tidy.
Your time is running.
Oh, okay. So some of our limitations that we encounter at the place, some of our potential challenges is high humidity in Makurdi, especially near the river. This high humidity can affect our sensors sensitivity. Another challenge is security. Monitoring at busy roundabout requires police and traffic wardens to coordinate for safety. Our actionable recommendations for regulation is emission testing for commercial vehicles, taxis and okadas. One of our recommendation also is for the community, for public health advisors, for street vendors to wear masks during the peak of traffic hours, which is usually around 8 a.m. and 4 p.m. Thank you.
All right. Thank you very much, Group A. From what has happened, though I didn't see you people working, I know that you have put in some meaningful time here. I will just wait for one question, one reaction from any person, just one reaction, and then we'll move on. Quickly, one reaction, one question, one contribution, we move on, not from the group members, from other people. Quickly.
Okay,
anybody?
You can raise up your hand and you'll be granted permission to ask your question.
Quickly. You have 30 seconds.
Sharp.
30 seconds, 30 seconds. The clock is ticking. We don't have time. So, yes, who is there?
Okay, I can see Tewase Wange.
Okay, give it to Tewase immediately. Tewase, what do you have to say?
Tewase, you have the floor. Don't greet us. Go ahead straight.
Yes.
Thank you very much.
Tewase, I said don't greet us. Go ahead.
My contribution to the presentation.
Not a contribution, a question. Prof said if you have a question, not a contribution.
The speaker did not make mention of regulatory compliance. So I don't know the recommendation the presenter of air will make to regulatory bodies like COP 29 and other regulatory bodies that we know. Thank you.
All right, thank you very much. Miss Susan, Miss or Mrs. Susan, please, can you respond quickly?
Okay, one of the regulatory compliance is for people to wear nose masks around at busy hours, such as 8 in the morning and 4 p.m. in the evening, and then the vehicle this thing should be tested to comply with the standard regulations for gas emission from vehicle, because we can bear witness that some vehicles have more gas exhaustion than others. So if we can implement monitoring the vehicles and okadas, I think we can regulate the amount of gas that is emitted during the rush hours.
Thank you very much. Thank you, Group A. Group A, thank you very much for that presentation, and we look forward for your submission. Submit your presentation on the platform, general platform. Do you understand?
All right, thank you.
So that
Yes, sir,
so that our HOD can assess them and probably form a policy paper from the contributions and materials information you are giving to us. Thank you very much, and that takes us to case study 2. Case study 2 is about the abattoir effluent discharge that is impacting River Benue's water quality here in Makurdi. I don't know whether this is Group Water or Group Abattoir. I don't know how you named it.
Group Water.
Group Water, okay, fine. That's good. Now, Group Water should come in and give us a 10 minutes presentation. Please be very snappy about it. We don't have time because we need to discuss all of this again. Thank you, Group Water. Who is there?
Okay, Omojo, can you raise up your hand? Please, ma'am, raise up your hand on the chat, and I will give you the floor to make a presentation for your group. Omojo, are you there? Okay, so just give me a second. Let me go check manually and.
Okay. So while he's checking, when you're ready, you just come up. I want to just talk about it quickly. You see, the abattoir area is a strategic point because it is close to the water body as well as a densely populated area around the lower, what they call lower level, not the high level, which is also a connecting point to in and out of the town. And that makes it very, very strategic. There's also another abattoir, which is downstream as you continue along the river bank. I wouldn't mention that. I'll see if they captured that too. These are areas that are strategic and calls for very important and detailed study. So I just want us to understand the relevance of this case study and the way it affects us, not just visitors to the abattoir, but other people who may be passing or transiting from one point to the other, and then that becomes a corridor. So having said that, I think Group Water should be ready by now to engage.
They are ready, loaded, and to fire. Fire, Mrs.
Okay.
Ms. Omojo. Ms. Omojo, on your screen, what you do is just tap on your screen. If you're using a phone, tap on your screen and the mic icon will appear on your bottom left, extreme bottom left. Just tap on it and your screen will be on for us to speak, for you to speak. It was a video you tapped. Tap on your type on the mute, the thing that appears there like a microphone.
I did this, sir. Well, sir.
Mrs. Omojo, can you unmute your mic? Yes, you're unmuted now. You unmuted yourself and unmuted yourself again. Just tap on it gently once. Who is presenting for the group? Maybe also raise up your hand so that while she also tries to unmute herself.
Thank you, sir. Thank you, sir.
The second person presenting for the group, raise up your hand so that I will ask you to unmute yourself.
I am very loyal. Okay. Thank you, sir. Thank you, sir.
Good morning, sir. Good morning, everyone.
Good morning. How are you?
I'm fine, sir. Can anybody?
Good.
Okay.
Go ahead.
Okay. Our case study is about the abattoir water influence entering into river bathing. So, our problem statement is abattoir operation in Makodi discharging untreated effluent, leading to elevated levels of suspended solids, turbidity, and reduced dissolved oxygen in the river, making the river unsafe for drinking and other domestic purposes. So our objective is to determine the special extent and the concentration of key pollutants such as BOD, COD, dissolved oxygen, total suspended solids, total dissolved solids, and other key pollutants. Then another objective is to model the dissolved oxygen SAG curve to know the amount of dissolved oxygen that has reduced in the river and the recovery of the dissolved oxygen in the river. Then another is to assess the compliance of our river water with the Nigerian standard for drinking water. So our matrix that we're trying to determine is surface water, which is water. Then our sampling location and justification. The first one, upstream. Our upstream will serve as our control site. This is the location where we believe that it's not affected by the abattoir effluent. Then our point of discharge is the actual location where the effluent enters into the river. And then our midstream is to assess the mixing of the pollutants or the mixing of the abattoir effluents and river water. Then our reference sites are water intake points and then fishing zones. Then the sampling technique we decided on is grab sampling. Grab sampling for parameters such as pH, temperature, all these parameters that are easily influenced by time and then temperature. Then composite sampling for TDS, EC, turbidity, and BOD. Then our replicates will take triplicates, which means we are taking 3 samples from each locations. Then our the equipment we decided on are portable multi-parameter probe for DO, pH, EC, and temperature. Then sampling bottles. Yeah, that's it. So our sampling, preservation, and handling for the DO, we'll store it on ice. Then for turbidity, we'll store it in a cool, high-density polyethylene bottle. Then with transport, we'll keep all our samples in a insulated cooler. Then for sampling, for seasonal consideration, we'll sample during April and April to July. For our key parameters are dissolved oxygen, BOD, pH, turbidity, TDS, total dissolved solid, ECs, TSS, total suspended solids, and then some metals. So for the DO, for the BOD, biological oxygen demand, it is 5 days incubation, which is the standard method for taking the oxygen, total oxygen demand. Then for pH, we'll do it in situ, we'll do it immediately. So we'll take real-time data for our pH. Same with temperature. Then for turbidity, we'll do same. For TDS, we'll do it in the laboratory. TDS, TSS, total suspended solids, and then for metals, we'll do them in the laboratory. Then for data management and presentation plan, like I said before, for our quality assurance and quality control, we're going to take triplicates, which means we are taking 3 samples from each location. Then we'll take field blanks and we'll take lab blanks so as to determine contamination. Then for the analysis, we are doing duplicate analysis in the laboratory. Then visual presentation, we are doing a bar chart to compare the upstream, the discharge points, the midstream, and the downstream values to compare each of them so that we can be able to determine how the level of contamination in each location. So we are going to display the data using a bar chart. Then we are going to use a time series plot to showcase the temporal changes or the seasonal changes in the river. Then we are going to use GIS mapping of pollutants concentration along the river stretch. And then we're going to use correlation plots for TDS, total dissolved solid against EC, and then regression models to analyze the relationship between both parameters. Then we're going to predict our dissolved oxygen SAM curve, which is to show the reduction of oxygen in the river. So our potential challenges would be limited availability of laboratory equipment locally, and then budget restraints for our duplicate analysis in the laboratory. So our recommendation would be to implement continuous water quality monitoring at key river points, both at the midstream, downstream, and then at the entry points of our abattoir effluents. Then would restrict, especially for areas that we know that are really contaminated, would inform residents around and will restrict them from taking water either for domestic or for drinking purposes so that they will not be affected by the pollutants. Then we'll do continuous monitoring in the area. Thank you.
Thank you very much for this presentation. I will just give some seconds for one reaction. You can bring down your hand. One reaction in the form of a concern, question. Quickly. One reaction, one question.
Okay. Mr. Evans, you are on. I've asked you to unmute yourself, Mr. Evans.
Okay, good morning. My question is, what are the likely sickness or diseases that are associated with the pollutants? Hello?
Yes,
Hello?
we've heard you.
Okay.
Yes, you've heard. What are the likely diseases associated with the pollutants?
Mrs. Yeah, Miss Gloria, please respond quickly. Thank you.
Or who is supposed
Or
to be the
anybody from that group.
co-presenter?
Anybody from that group.
Mr. Wange, are you the co-presenter? I've asked you to unmute yourself.
No, I'm not.
So hold on.
I have a question.
Yes, who is responding? Miss Gloria, are you responding? Or somebody else from your group? Group Water, please.
Bem Agba, I've asked you to unmute yourself. Are you responding on behalf of the water group?
Yes. Good morning,
Okay.
Doctor.
Okay.
Good morning, Cosrep. Good morning, everyone.
Don't greet us. Go ahead, sir. Time
Okay,
is going.
so I want to respond. I am from the water group, and as we know, one major concern for abattoir waste is the fact that they are mainly organic waste. So, a major disease or sickness that could come as a result of the disposal of abattoir waste into the water. Apart from the disease, we know that eutrophication will be a major challenge, especially, knowing that nutrients from the waste will be channeled directly into the river. Also, for specific disease, cholera is a common challenge because we know that cholera is associated with both human waste and animal waste. So these are some of the challenges that these are some of the diseases and the challenges that comes with disposing fecal coliforms from animal waste and human waste, abattoir waste, blood, and the rest into the river. Thank you.
All right, thank you. The water group or Group Water. I want you to also package this presentation your group has made, and I think the best thing is to send it to Angle. You should collect it and send it to me, so that
Yes, sir. We will
yes,
collect
collect all of them.
that,
Collect all of them. Then you send it to me. I will then forward it
yes,
to HOD
with all the group members.
Yes.
Okay, sir.
I have to get that so I can collate and send to HOD, and we'll take it from there.
Okay,
Yes.
sir.
Yeah. Thank you very much. So let's go to the third slide quickly. We are running out of time. The third slide talks about the effluent from the rice processing factory, the way it's affecting River Benue water quality, and I don't know what name you tagged this group now.
It's a food group, sir.
Okay, food group. Okay, group food. Somebody should come up and make this 10 minutes presentation quickly. 10 minutes presentation.
You can make it 5 so that your co-presenter can also step in, because there are 2 presenters per group.
Okay, that's fine. But if one is prolific enough to run through it, so I will save time, that will be fine too. The second person, one can run through it. The right person will be ready for the question, the response. You understand?
Yeah. Mr. Bemagba, can you lower your hand? Please, lower. Okay, let me help you lower it from here. Okay. Jennifer Agba, are you speaking for the group? Jennifer, you can unmute yourself. Please raise your hand up.
I'm not speaking for the group. Now we have gotten to group 3, I think. Don't worry, I'm not group 3. Thank you.
Okay, food group, raise up your hand. Who is speaking for food group? Raise up your hand so that you can be unmuted to speak. Okay, Vera Gabriel, you are on now. I've asked you to unmute yourself.
Good morning, everyone.
Good morning. Go ahead. Time is running.
All right. I would like to talk on the effluents.
Who is the next person that is supposed to compliment her? Raise your hand up too, so that, because we can't hear her again. We don't have so much time.
Okay. I would like to talk on the effluent from rice processing factory affecting River Benue water quality Makurdi, in bracket water/industrial pollution monitoring, under the food group. So first of all, I would like to talk about the problem definition. The environmental problem is the pollution of River Benue caused by untreated effluent from a rice processing factory. This effluent contains high organic matter, suspended solids, and nutrients which can reduce water quality, affect aquatic organisms, and make the water unsafe for human use. Now, when these organic matters enter the River Benue, it acts as food for aerobic bacteria. As these bacteria multiply to decompose the waste, they consume the dissolved oxygen in the water, which is the DO. Now, the oxygen sag leads to a drop in DO levels downstream, which you aim to quantify. Secondly, we are going to look at the monitoring design and sampling strategy. This actually explains how we plan to collect our samples so that our result truly shows the impact of the rice processing effluent on River Benue. Now, what are matrices? Matrices are the environmental media you are sampling from. Now, our choosing matrices is the water, which is the primary matrix, and then the sediment, which is the secondary. Now, why do we choose water as our primary matrix? It is because the pollution source in liquid effluent and River Benue is a surface water body. Water is the most relevant matrix. Why do we say, okay, sediment as the secondary matrix? We chose sediments because they can accumulate pollutants over time and reflect long-term contamination. Our sampling locations, sampling points and justifications. Effluent discharge point represent this pollution source. Now, the upstream of the discharge point serves as a control site present natural river conditions before the pollution. Now, let's look at our sampling techniques and equipment. We are looking at the grab sampling for effluent and River Benue. Now, why do we choose the grab sampling? Because it captures the water quality at a specific time and is suitable for routine industrial pollution monitoring. The equipment we use: clean polyethylene sampling bottles, pH meters and thermometer in situ measurements, cooler box with ice packs, Van Veen grab samplers for the sediment, then sampling, preservation and handling. It prevents changes in water quality before laboratory analysis. Preservation method can be used. Now we have the BOD. It's stored at 4 degrees Celsius and analyzed within 24 hours. We have our COD, preserved with sulfuric acid. The nutrient refrigerated at 4 degrees Celsius. That's proper preservation, ensures the integrity and the reliability of the analytical results. Now, in summary, I would say the monitoring design involved water and sediment sampling at the effluent source, upstream and downstream locations, using grab sampling techniques with proper preservation to ensure data reliability. Now, let's look at the key parameters and the pollutants. We are looking at the pH, temperature, electrical conductivity, that is our EC, turbidity, total dissolved solids, total suspended solids, dissolved oxygen, biochemical oxygen demand, chemical oxygen demand, that's COD. Now, proposed analytical techniques. We have our portable pH, EC, TDS meter, turbidimeter, Winkler titration method for DO, 5-day incubation method for BOD, and then dichromate reflux method for COD, gravimetric method for TSS. Now let's go down to our point 4, which is the data management and quality control. Now our data management and quality control, under our feed blanks, we have the bottles of distilled water treated exactly, and then it shows, the blank shows the pollution, and then an oxygen sag curve is a standard environmental engineering graph that visually proves the suffocation of the river to non-scientists, such as the factory owners or the community leaders. Now we look at our limitations and our practical recommendations. Now let's look at the power factors. Since BOD tests require a constant 20 degrees Celsius for exactly 5 days, the laboratory power reliability is a major risk to data accuracy in the Nigerian context. Now let's look at our solution. Instead of just stopping the factory, we recommend sedimentation and aeration. Sedimentation tanks allow heavy rice particles to sink, reducing the TSS, and aeration ponds force oxygen into the water, reducing BOD before it even touches the river Benue. By recommending this principle, we are suggesting that the factory should bear the cost of the monitoring and cleanup, moving the burden away from the Makurdi community. I think I am done.
Okay, that is it from your group, right?
Yes, sir.
All right, thank you very much. That was good. Thank you very much. One concern, one reaction, please, quickly. One reaction, one concern, one question. Quickly. Nobody? Angu, what is going on? Hello?
We are with you, sir.
Yeah. Where is the class rep? Miss Angu? Is that Ongu? Are you
He has
back?
asked students to step in. I don't know.
Okay. Susan now step in, coordinate while he tries to come back. One
He said no.
One reaction, one question, one concern. Anybody, please raise your hand so that Susan can allow you. Any raised hands? I can't see any. Okay. Okay, Ben, go ahead, unmute yourself. Ben, go ahead, unmute yourself.
Okay, so
Yeah.
well done. I just want to know, because you didn't inform us, what statistical tool are you using to display your data? You didn't tell us about your results presentation. How are you going to analyze to know if there has been a significant impact on the river from the waste? Thank you.
Sorry, can
Please,
you come again with your question?
He is saying that you did not present your statistical technique for data analyzing. How are you prepared to analyze the data you are going to collect or you collected during your sampling and all that? So that's what he wants you to tell us. Vera, did you get that? Vera, you can.
Vera, you can unmute yourself.
Okay. Angu, you are back.
I'm back, sir.
Okay.
I'm in power.
It's okay, that's fine. You're welcome back.
Bacha is if he's in power.
Okay.
Okay, Vera Gabriel, are you in power? Okay, maybe I should try. Okay, Mr. Ajoko, you were supposed to be Philemon. You were supposed to
deputize her. Can you maybe step in? Raise up your hand so that we can unmute you to step in. Mr. Ajoko, are you there? Okay, Mr. Ajoko is here now. Unmute yourself and step in. The statistical method the team wants to use in analyzing the data they.
Yeah, I will start from the objective of the study. She left out the objective. I was actually going to be the lead presenter, but I think there
just
are
go ahead.
so
go ahead. There's no time. Go ahead, please. Just go ahead.
Yeah, I will quickly state the objectives of the study. Number one, we actually going to quantify the spatial degradation of the water quality downstream the rice processing plant. Again, we're going to assess the organic and inorganic pollution load. And then the third objective is to evaluate oxygen depletion and determine ecological risk to aquatic habitat using transit-based sampling and pollution indices. Now, quickly to the statistical method that will be used here. Number one, we'll be using ANOVA. Here, we'll be using ANOVA to determine the difference among the stations. Remember, we're going to, during the sampling method, we use graph and sampling. We also use transit sampling, which is distance-based, and we had like 5 stations. Of course, we have an outfall station, and then the other stations A, B, C, D, which represents the initial point, the middle point, the far point, and then the extreme point. So we're going to use ANOVA to test differences among the stations. And then we're also going to use a regression that will be, we are going to test between distance versus recovery again. And then for BOD versus DOE, we are going to use Pearson correlation. So quickly, I want to talk about limitation, and I want to add to what she said. She talked about our limitation. One of the major limitations is the refusal of the HOC officer, that is Health, Safety and Environment officers, denying us access into the premises. For some reasons, they think, and then another limitation is political interference. Because some of these politicians, when they set up these factories and you try to assess what is wrong, they term it politics. Then for quality assurance and quality control, there are institute QC and QA. Of course, she made mention of that, but we are going to ensure that our instruments are calibrated to give us real-time accuracy. And then for quality, we are going to duplicate our analysis to ensure precision, and then we use certified reference materials to ensure validation. And then one of the major recommendations we'll be recommending is that the factory should not be shut down, but then during the EIA, they were supposed to build an effluent treatment plant. So if that has not been done, we'll look at we'll assess the risk. So if the risk is high, we will shut it down. But if it is as reasonable as practice, we will give them time while they complete the E2P plant. And then for the stakeholders, for the regulatory compliance, we measure the parameters we've measured in the lab with the standard of natural and World Health, as the case may be, so that people will not lose their job, and then the company as well will complete the E2P plant, and then overall to safeguard the environment and ensure sustainable development. Thank you.
Thank you very much, Mr. Joko. That's a good one. On that note, please ensure that this document is submitted to the class rep for further processing. Thank you. And that takes us to the 4th group, which is the 4th case study here. We are looking at heavy metal contamination in soil and plants at Goza dump site, that is Abuja. Focus is on the soil and biological samples. I don't know what you tagged this group, class rep.
Yes, sir.
Group what?
Is the Earth group.
Earth group, okay. So let's have Earth group's presentation.
Earth group, are you ready, Earth? Who is presenting for the group? Maybe you raise your hand up. Mr. Joko, you can raise up your hand. Abdul Malik, if you're not presenting for the group, you can raise up your hand. You can, sorry, drop your hand. You know, only the presenters, maybe the two presenters of the group, their hands should be up. Okay, Abdul Malik, your hand is still up. So let me ask you to unmute. I guess you are the one presenting for the group. Over to you, Abdul Malik Mohammed.
Good morning.
Good morning.
Good morning,
Malik,
everyone.
how are you? Good morning.
I'm fine,
Go
sir.
ahead. Good
Yes,
morning.
sir.
Yeah, go ahead.
So, course rep, our group is Soils Group. It's not a Earth Group.
Okay, sorry.
Yes,
sorry.
case study 4. So we'll be discussing the case study, heavy metal contamination in soil and plants at Goza dump site in Abuja. So we have to define our problem. We have to define the problem. The main environmental problem is leaching of toxic heavy metals from decomposing electronic waste, which is the e-waste, battery, and industrial scraps at the Goza dump site in the surround, and how it moved into the surrounding, and later being subsequently it is being uptaken by the plants, which are all by the vegetation, which is the crops and the plants. So we'll look at the objective. Mainly, we have a lot of heavy metals, but we'll be determining the few ones, which is the lead, cadmium, chromium, and we'll be discussing these three majorly because of our time. We'll be researching on these three majorly because of our time. In the soil, that is how the depth of them in the soil, distance from the dump site occur to assess the transfer factor, which is the TF of these metals from the soil into the specific plant tissues. So how they move into the plant tissues, we'll be looking at that. This is one of the objectives. So we'll be looking at the monetary design and sampling techniques. So metrics, we'll be looking at the soil. So we have to divide our soil into the topsoil and the subsoil. So those are the two areas we'll be concerned with. And biological. Under the biological, we'll be looking at the dominant plants species. That is, after our visitation to the site, our visitation to the site, we'll be looking at the two areas which are going to mainly be mainly there will be the dominant plant species and the crop found on the site. Those are the two things we'll be looking at. Those are the two plants we have been concerned with. Then we'll look at the sampling. We'll sample the location. A systematic grip. We'll be using a systematic grip sampling approach. The point will be at 5 meters interval, 50 meters interval down the gradient. That is, we'll be looking at the 50-meter interval down the gradient travel pathway. That is how the depth. And at a control site of 2 kilometers away from the baseline. Sampling techniques and equipment. Mainly the soil, that is the manure soil for depth, that is the depth of the manure soil will be 0.5, and at the same time we'll be taking 15 to 30, 0 to 15 centimeters, and another depth of 15 to 30 centimeters. Then the plants, manual uproot using plastic. We'll be taking our sample using what we call the plastic tour to avoid metal contamination. So we'll be using a plastic tour to take our plants so as to avoid contamination. So, and again, to allow representativeness of the plants, sample preservation and handling. How we are going to preserve our samples. The soil, will place it in a labeled polyethylene polyethylene, which is the nylon bag, hair dried at room temperature. We'll dry the roots at room temperature and sieve through a 2 meters mash or a sieve.
Who is the co-presenter for the group? Please raise your hand up so that you can compliment Abdul Malik. It's as if network has kicked him out or something. Please, we don't have time. We still have one last group to make a presentation. Who is the next presenter? Who is the co-presenter for the group?
Who is coming on for this group? Mr. Ngo, do you have their list?
Yeah, there's a list here.
Call up anybody from the list. Call up anybody from the list. If they don't respond, they will lose the marks.
Mr. Ephraim Bo, Nite Jalson. There's a resident engineer in that group too. Bashai. Global Flavor. Abi Favor. John Paul Over. Please raise your hand up. You are very knowledgeable people. Say so, Ahangba. You are there. Sugar
come
Rush.
up or lose the marks. They should come up or lose the mark.
Veronica Innovation, Winnie Yandi Adomomi, please. There are very formidable people in that group. Okay, Nite. Barnabas, you are there now. Barnabas, over to you. I've given you permission to speak. Nite Kwado Priscilla too. You can unmute your mic and carry on from where Mohammedu Abdul Malik stopped. You can unmute your mic. Nite, you are on.
So he stopped at where did he stop? Okay, he stopped at sampling locations.
Please continue from there, ma.
Okay, so we are talking about the plants now. So he said, in continuation of what he was saying, manual uprooting. That's we are using manual uprooting method. Using of plastic truss to avoid metal contamination because of those heavy metals that are there. Then we use a representative because in the other class the doc said the plant has to have the atmospheric representation there. So the same species has to be on the same line. Then we had sample preservation and handling. Under sample preservation and handling, the type of soil. Soil was placed in a label polyethylene bags, which was dried at a room temperature. And sieved through a 2 millimeter mesh. Then the plants were thoroughly washed with distilled water to remove the surface dust and oven dried at a temperature of 70 degrees Celsius. And also pulverized. Then the analytical techniques and method we selected for this procedure, the key parameters due to the heavy metal pollutants, that's the lead, the CD, the CR, the nickel. Then the soil type, that's the pH. The pH has its effect or affects the metal mobility. Then we also proposed analytical technique. The analytical technique we made use of was the ENS. We used it because it's highly sensitive for trace metal analysis and is widely available in most Nigerian universities and also regulative bodies. Like we have them in the NESRA labs and NAFDAC, and is also cost effective for large sample batches compared to the inductive couple plasma and mass spectrum. That's the ICP2 MS. Then the data management and presentation plan. That's the quality assurance and quality control measures. Use of satisfied reference materials, the CRMS, for soil and plant tissues. Sorry, I'm on transit. That's why I'm talking like that. Analysis of field blanks to check for cross-contamination. Then triple replicant analysis of 10% of samples to calculate the relevant percent difference. That's the RPD. Then visualization tools that we made use of was the GIS heat maps to show the spatial distribution of the hotspots of the contamination around the Guzabe dump site. Then we also did the bioaccumulation factor tables. We made use of it. That's to compare the metal levels in the soil versus the plant tissue. Then the limitations and recommendations we arrived at or we looked at, that's the potential challenges. We have the safety health. Because due to this dump sites there, we are going to face some health challenges like having of diarrhea, cholera, typhoid. So potential exposure to these pathogens will give rise to these sicknesses that I'm saying from the dump sites. Then we'll have seasonal variation. That's metal concentrations may dilute during the rainy season. So when you have concentration of it during dry season, so it requires multi-seasonal sampling for accuracy. Then actionable recommendations for regulative bodies like Abuja Environmental Protection Board, that's the AEPB, immediately should restrict farming activities within that dump site from a range of 500 millimeter radius from the dump site. The industrial community implementing a mandatory sort at source. This program is very important because when we try to practice the way they do in other Western countries, trying to sort our waste before taking it there, it will really go a long way to prevent these heavy metals from entering the general waste stream for environmental sustainability for ourselves. And this practice will be done from the house. We have to start practicing of dividing our waste bins from removing the e-waste from the normal decomposable waste before they take it to the dump site. That is why some NGOs, regulative bodies like NESRA or some communities are creating awareness now of sorting of waste before being decomposing and also encouraging of recycling. Thank you for listening.
Thank you very much for the presentation. We just will entertain only one concern, one question, one concern, one oversight that you feel that they have. One person, please, quickly.
Any concern?
Hello.
Okay, George Okuma.
Okay. George,
George, unmute yourself.
Please, I want to know what sampling technique was used to collect the samples? Because they collected samples from the soil, root, and then the plant. What sampling technique was used? Thank you.
Okay, the sampling technique was AS. Group soil.
No, he's talking about what sampling technique was used in collecting data.
Okay,
in collecting sample.
Okay, in collecting sample of the soil.
Not the testing technique.
Okay, yes. Sorry for that.
Yeah, respond.
Respond, man. Okay, Abdul Malik is back. You can unmute yourself and help respond. Abdul Malik, unmute your mic, sir.
Sampling technique for the soil.
For sample collection, sir. Abdul Malik, are you there? Unmute yourself, sir.
How did you collect your samples? That's just the question. How did you collect your samples?
Okay, Barnabas, over to you, sir. Unmute yourself. I've asked you to unmute yourself. You're a member of the group too. Barnabas, unmute yourself.
You're not allowing me. Can you hear me now?
Yeah, very well.
Okay, good afternoon. Good morning, sir.
Just
So
go
for
straight to the
samples were collected in two forms. The soil samples were collected using the auger. An auger is this device you put into the soil and then you take samples some meters below the surface. And then for samples were also collected from the roots of the plants around the study area. The plants were uprooted and the soil that are held onto the plants were the soil samples that were taken for the analysis. Thank you.
Okay, thank you. Now,
you want to say something? Go ahead.
No, I'll contradict to what he's saying. Just continue.
Why will
you want to contribute to what he said?
No, sir.
No, you are free. You are free. After this, we move on.
Okay, no, the auger is it, but I was thinking you're asking of what they were using to collect the sample. That's what I was trying
Okay.
to say.
Thank you very much, group Soy. Let's go to the next group, the fifth case study. The fifth case study is heavy metal pollution and of soil around the solid waste dump site in Abuja. Hello, unmute yourself, please.
When you finish speaking, mute yourself.
Fifth case study is the heavy metal pollution of soil around solid waste dump site in Abuja suburbs. We're looking at Kuje, Kwali, such areas. And I don't know what name you tagged this group, Consrep.
It's the Earth group, sir.
The Earth group.
Earth. There are people of the Earth.
Okay, people of the Earth. Okay. Who are there? The people of the Earth. Why were the people of the world, ba?
Why we are in the world of the Earth?
We are in the world of the Earth. Okay. Please, who is there? We are running short of time and even power.
Raise up your hand.
My battery is gone. Hurry up, please.
Okay, praise. Your hand is up. You can unmute yourself. I don't know whether you have to speak for the group. But Barnabas Bashiri, you can Bashai, you can lower your hand. Okay, Mr. Dogara, unmute yourself.
All right, good morning.
Good morning. Go ahead, please.
Good morning, sir. Good morning, everybody. My name is Praise, and I'll be presenting for Team Ed, our case study on heavy metal pollution. Using the Kuje
sorry, there is noise coming from your end. Maybe you are aware it's noisy. Please, can you?
No. I'm not enough. Can I continue?
Yes, ma'am.
Yeah, go ahead. Sorry, Dogara, can you mute yourself, Dogara?
Okay, sir.
Aha. Anytime you want to, you can raise your hand so that the class rep will allow you. But for now, just mute yourself.
All right. Can I continue, sir?
Go ahead, my dear. Go ahead.
All right. Kwali and area councils and they are located in in the southern part of Abuja. They are kind of semi-rural suburb transitional settlement, and basically Kwali lies in between. I think lies in the southern parts, like I said. So there's a growing settlement with road networking and farming communities around there. In relation to the case studies to the site, close communities farm makes the soil vulnerable, contaminating and contaminated and down to the littered movement. Now I'll be talking about the background and the background of the studies. Now, solid waste management remains is a major concern and a challenge in our environment, especially narrowed down by case study, which is the council area. Now, what is the open site? It is usually characterized by the mixed municipal waste, mixed municipal waste. This site no lining, no garbage activity, no to home, and then that's a environmental problem here. The key environmental concern here is the accumulation and migration of toxic heavy metals in the surrounding soil, especially now metals enter the soil, natural infiltration, as the composition containing e-waste and scrap. Why is this?
Can you maybe step away from where you are? I think there are some other devices there and there are some interferences.
I don't think it's from my end. I'm in a quiet environment.
Okay.
I can go.
Please continue.
All right. Why is it? Because one, reduce soil quality and fertility. Now, heavy metals persist in the soil for a long period of time. It can prolong, it can pose a long risk for human health through food consumption. The main objective is to assess the extent of energy and the quality site, to determine site, to compare measures and concentrations with and the Dutch soil standard. Now, to quantify heavy metals concentration, that is the lead, the chromium, the zinc, and the iron in the soil. Of different depths, provide evidence-based recommendations for regulation, design, and sampling strategy. Our monitoring design will be on soil matrix, the soil matrix, the soil medium of contamination, which is a pathway for groundwater. Now, the study of the Kuje Area Council and the Kwali Area Council, which are some spatial design. The spatial design will help so that we'll be able to, and then the sampling size will be established down to the 200 meter, and then the depth, the sampling depth, which is a vertical design. Now I move over to the sampling equipment. Our sampling equipment will be the soil auger for the soil auger, polythene bag for collection, and then permanent marker for leveling. Now, how will the sample be handled in presentation? To ensure integrity, we have a clean polythene bag for collection, well labeled with location, depth, distance, dates, and sampling IDs. And then sampling will be transported down to the laboratory under controlled and clean conditions. Now we're moving over to the analytical techniques and method selections. Now the key parameters, which are the cadmium, the zinc, the iron elements of the soil for the soil geochemistry and interpretations. FAST, which is the flame and atomic absorption spectrophytometry. Why would we be using that? It's appropriate because it's widely acceptable for heavy chemical determination in soil extract because it provides reliable and precision and accuracy. And we can find that mostly in laboratories in the FCT, which is one of them is the University of Abuja laboratory. Then we'll move over to our data management and presentations. Our data approach one will be using the descriptive statistics, which we're using the descriptive statistics to quantify the mean, the maximum, medium of concentration, and then the comparison across the distance and the depth. The pollution load index will be used to provide overall contamination for the rating of the dump site. And then our data presentation tools will basically be used to display the depth profile, the distance gradient, the pollution index, the index compared to the Dutch soil standard and the WHO. And then our maps, which gotten from the GPS, will be used to show the location spotlight for the presentations. Now, our expected findings will be based on the dump sites, the contamination patterns. We'll be expecting to check the highest metal concentration from the 0 meter mark zone to 15 meter zones, the top soils from the 0 to 15 centimeter, likely to show the greatest contamination due to ash decomposition, direct dumping and burning residues. Cadmium and lead may also show the risks at which it may also show the risks even at low concentration due to toxicity. Then for the deeper layers, which will be between the 13 centimeter down to the 15 centimeter, will help to show either it's a reduced concentration if the metals are retained in the topsoil, or it's increased concentration if leaching is significant. Now, what's the limitations and the few challenges? Now, the limitations will be now access and safety issues. Why access and safety issues? Because some sites may be restricted because some sites are privately owned, while some are actually open. So what will be the main challenges here? The scavengers may limit the movement and disturb sampling points. Now, the heterogeneity of the dump site, waste composition is uneven. And even then, the main challenge they will be getting will be the contamination. Maybe the contamination can be spotty, meaning the battery dump areas, the food dumps, and then several other dump sites. Then the seasonal variation. Now, seasonal variation is also a limitation here because it increases leaches transportation. Why the dry season? That is for the rainy season. Why for the dry season? Increased dust and ashes distribution. Now, how do we control this? It's uncontrollable because the soil may be difficult to find an expanding settlement. Now, what would be our recommendations in this? Now, our peer recommendations would be to the AEPB, that's for the area councils, and then the NESRA, down to phase out open dump sites, which is actually a problem, to phase out open dump sites and open burning. Now, to enforce a strict prohibition of waste burning, and then to transit into sanitary landfills. Then to install clay liners and leachers collection system by routine environmental monitoring, and then e-waste control measures for regulation of the deposition of or dumping of the batteries and electronic scraps from metals. Now, the recommendations will be on 3 sides. Now, to the communities and the farmers, they should avoid planting edible leafy vegetables around those dump sites. Then restriction of grazing near those dump sites. Then community sensitization should be effectively carried out to create an awareness about the implications of those dump sites to the health of the people. I think the next person will carry out from there. Thank you.
Okay,
Hello, please,
Mr. Dogara, you can carry on from there. I've asked you to unmute yourself.
All right. Thank you so much, sir. Just like she said, the recommendation is based on the three categories, which is for regulators, the Abuja Environmental Protection Board and the area councils are the ones we are recommending the phase out open dump site and open burning for them to be used. Then we enforce the restrict prohibition of waste burning. Then we look at the feature research. For the feature research, expand to include the groundwater sampling, that is the borehole and wells, include other matters like the CR, the nitrogen, depending on the budget. Then we need to conduct also a health risk assessment for local exposition pathways. Then the conclusion, this case study highlight a real and pressing environmental sustainability challenge in Abuja suburbans. Heavy metals contamination of soil around open dump site in Kuja and Kwali. Through a structural sampling designed, a radial plus depth profiling laboratory analysis using the FAAS, which is our techniques, and interpretation using the pollution load index. This study provides a strong scientific evidence to guide our environmental protection policies to safe agricultural practices in that very particular area, and also to improve the waste management planning in that very particular area. Thank you.
Thank you very much. Any questions? Any questions, please? Prof just took a short break. He's joining us soon. Prof just took a short break. He's on now. Prof, you're on now. You can
Yes,
off
I
your
am.
mic.
Thank you. Yes.
Yes, sir. Yes, sir.
Can you hear me now?
Yes, sir.
Okay, good. Thank you very much. Yeah, thank you for the presentation. I want a particular concern to
Prof,
be heard.
you can also see their slides. I'm sharing their slides.
Yeah, that's very commendable.
Recommendations and feed limitations, stroke challenges.
Yes.
Expected findings, scientific interpretations, and data management, Q&A and quality control. So the slides are there.
Yes. Okay.
The techniques they use.
Yes. Thank you very much. We collect this and then work on them going forward. Now, are there concerns? Let's take one concern because we are really running out of time. One concern. Anybody? No concern.
No, George Okuman, your hand is up. You can unmute yourself and speak, sir.
Good morning once again. Prof, this is actually directed to you. I don't think it's to the group per se, but the group may answer. I have noticed this dump site. I've noticed that any plants planted around them flourish. But Pray said we should avoid planting or eating any vegetables, plants, or any crop around them. Are they actually safe for consumption compared to the ones we use MPK and this other fertilizers? Thank you very much.
Okay. Yeah. Why they flourish? Why you see them flourish? I mean, the plants is because they are exposed to very high amount of organic manure, organic nutrients. So they flourish very well in abundance, in excess of what they need. They flourish. But the group's concern is around the presence of contaminating heavy metals. In as much as they have these organic manures and nutrients, while they grow, they take up these heavy metals, and these heavy metals are lodged in their various parts, be it the leaves, be it the fruits, be it the stems, be it the crops, the grains. So the concern is, while we see them as flourishing and while we also see them as very attractive for our tables, we are inadvertently ingesting heavy metals into our system. These heavy metals are bound around this dump site because of the wastes that are, we have mixed waste being dumped at these various spots. Waste from items like batteries that have been discarded, waste from plastics, waste from all manner of things, electronics and all that. And these heavy metals find their ways into these plants and are deposited at these various parts. And these are the ones we consume. Yes, they look good, they look greenish, they look very fine, and they are there for us. That is the organic part. The other part is the toxicant accumulation. So that is the concern of this group, and that is why they are advising and recommending that we don't plant crops around such dump sites. They may be looking good, but they are dangerous. So that is the major thing. It's not about how rich or good looking they are. It's about how safe they are based on what they come in contact and what they pick from the dump sites and transport along their food chain per se. I don't know if that answers to your concern. Hello? Hello, George. George. Okay, you have been muted. Okay, fine. So I hope that answers to your concern and gives clarity to the implication of having them around the dump sites. So having said that, I think we'll have one more group to go.
Hello?
Hello? I've been given
Yeah.
the opportunity for one question.
Yes, sir.
Go ahead, man.
Hello?
Yeah. Prof, please, I just want to know the difference between soil and earth. What's the major difference between soil and earth? Thank you.
Okay. Soil is a component of the earth. The earth is made up of the soil, other materials, inorganic, organic materials that are found within the earth surface. Soil is not the only thing that makes the earth. The earth has water, the earth has other solid, the earth has rocks, the earth has pebbles, the earth has even dew, and the earth also has what do you call them? Synthetic materials that are there. But the soil, as it is, has definitions that are distinct based on the professional angle you are coming from. What we call soil in agriculture is basically a composition of a material that is born of silicon dioxide, which is the sand you see, but with a component humus, which is the organic part, clay, and any other material that may form a bedrock for the growth of microorganisms and plants. That is soil. So soil is a component of the earth. Earth has the soil and other materials contained in it. I don't know whether that clears it for you.
I have also a concern here too.
Okay. What's the concern now?
Yes, thank you, sir. You know, our dump site, especially the site they are using in Kuje, there is the organic and the inorganic part, which they have explained the inorganic pollutants. But there's another silent killer. I look at it from the organic side, which is PFAS. You know, PFAS is made up of fluorine, which is highly electronegative and highly reactant. And most times, these PFAS react with proteins to form toxins that over time in the soil or in the water, when plants or animals take it up, it results to bioaccumulation and eventually leads to low immune system responses in aquatic life, in some jellyfish and so on. So how do we manage and check these menace? Thank you.
Thank you very much. If you look at if you look at the presentations over these few days, you will discover that PFAS, that name PFAS, that acronym keeps popping up. It is not just from the fish. Let me take our minds back to us. PFAS are okay. A component of PFAS is with us every day of our lives. If you go home today, pick up your toothpaste. Almost every toothpaste you have in your house, which you use every day, has the fluoride content in it. That is another very dangerous source of fluorine. And we use them every day. Whether we like it or not, fluorine goes into our system. What matters now is the amount of this fluorine that we ingest and how we ingest it. You imagine a little child that wouldn't know this risk, and they swallow the toothpaste when you give them paste to clean up their teeth. So the fluorine thing, the fluoride contamination is on the increase, and explains to an extent why these days we have a lot of immune case health issues. People come down with so many kinds of diseases because of immune compromised immune systems. Then PFAS also, the one that is most dangerous are the ones that are volatile, that comes from the plastic pollution based on degradation, either by UV initiated or thermal initiated degradations. But give or take, PFAS as it is, and its effect, damaging effect, can be mitigated for now, not completely eradicated. So we watch things that we use around us. Even some, it's a very potent antibacterial and So you discover that it's also a necessary evil. But what we need to be careful about, because up to now, we've not found a very competent substitute for the fluoride ion when it comes to its antimicrobial effect. But the thing we need to be careful about is the one, source, two, ingestion, three, the quantity. But we cannot, as it is right now, completely run away from coming in contact with PFAS. But they are there. We don't have to run away from that. They are there. So what do we do? One, every day, because they go in and their ionization potentials are very high, we tend to look for foods that can easily react with them and bring them out of our system. And we need to first hydrate our systems properly, take a lot of water so as to ensure that when they form some of these complex compounds in our system, they can be deposited and flushed out. Two, ensure that we reduce or cut down to very, very minimum quantity the amount of house care items that we use that contain the fluoride or fluorine components. Three, we are supposed to be careful with the kind of plastics and the handling methods. But we can't run away from that, because even our executive seats in the offices are also made from plastic materials, and these plastic materials have phthalates and other additives that are used as compounders and extruders, extenders during the manufacturing process. So anybody telling us that we can completely, at this moment, eradicate PFAS is not living with the reality of the time. All we can do is to mitigate the effect while we are still searching for a very healthy substitute for PFAS. Yeah, the polyfluorine aromatic materials are there. They are very much around us. We only try to live with them and cut down on the level of contact with them. That is the situation as it is right now. Thank you. I hope that at least answers to your concern. But I'm not trying to scare you with the toothpaste thing. No, I don't say go, don't use toothpaste again. No, no. But
Well,
we
I
can
understand.
we can check the toothpaste we use. There are some that actually they don't have these the fluorides. You understand? But those ones are a little bit pricey. Don't go for names. Go for composition, content. If you are going to be very careful, and for those of us that have children, ensure that their toothpaste, at least their toothpaste, are fluorine compound free. That way, you try to protect them. But well, what can we do? There are certain things we don't have control over. Look more so looking at the economic situation in the country. These things are so horrible, but we try. We try to eat some foods that are healthy, that can, get into our systems and help us flush these things out. There are many of them. We still do all manner of things. We still use, we still drink our water when we have them in our cars. We lock up the cars and the waters get heated up. When you go into your car, you switch on the AC. After a while, the water gets cooled and you take them in. I will tell you for free that you are at that moment taking in some elements of synthetic material, synthetic plastics. Because anytime the temperature around the plastic increases in the presence of water, increases to say 50, 60 degrees, there is gradual leaching of materials from that plastic, particularly rigid plastics like PET bottles, which is a very common item we use. Our bottled waters now, they are made from PET bottles. So for rigid materials like PET to be made to be flexible to form bottles, they incorporate materials like they call plasticizers. These plasticizers have been implicated in certain carcinogenic activities, and they leach out at slightly elevated temperature. It's a gradual leaching that you won't even notice. It doesn't change the taste of the water. It doesn't change the color of the water. It doesn't change the appearance in any form, but they are there. So, but walking, the car is heated up, the bottle is heated up, the water is heated up. You put on your AC or you allow air to circulate. After a while, the temperature comes down and you gulp down the water. My brother, my sister, we are gradually taking in these things, but it doesn't stop us from taking precautions. The same thing with even the sachet water. That you will not get the phthalates from there, but you get certain things from the paint and the other they used in their identifications and all that. So whichever way we look at it, whichever turn we take, we come in contact with this. So that is why I said mitigation is the right way to go as it is right now in this country, until we get to the point where we can use basically natural materials and not the synthetics, which I don't think is going to happen in the very near future. But we'll keep going. God will keep keeping us. I hope that answers to the concern.
Yes, sir.
Okay. Any other concern?
So I don't know whether I should share something that happened today in the house.
Go ahead.
Thank you very much. Today I said in my house, let me help the house by also cooking. So when I got to the kitchen, palm oil is stored in a bottled water, basically plastic, polyethylene. And I discovered that the palm oil, before I can use it, it was clogged. So I wanted to increase the temperature so that I would turn it from solid to liquid. So in the process of doing that, I discovered that I overheated the plastic bottle, and the plastic bottle started melting and the oil started dropping a little bit. So at that point, I took a decision that I won't use it anymore because it's now contaminated with microplastic or nanoplastic that I can't really see. So I disposed of it. I don't know if my decision was correct.
Yes, your decision was or is 100% correct. Though economically, madam will shout, oh, But but as as an environmentalist now, that's what I know you people as right now. Your decision, yes, very, very correct. At that point, it's not just the microplastics. Like I mentioned, the phthalates. The phthalates must have leached into the oil. And the thing is that they are even more susceptible to being attracted to oily environments. So it's a very good decision that you took there to ensure that you don't poison your family. But sir, I don't know the quantity that you discarded, and
But
I
some
can
must
tell you
have
for
got to.
I hope madam did not quarrel, but the fact still remains that yes, there was contamination at that point. There was pollution at that point. Yes, that's correct. But at the same time, like I said, we are only trying to mitigate. First of all, we need to know where the problem is, how it gets to us, which this cause is exposing us to, and then how do we manage it for now. So he's correct. Next time, I think the best would have even been for you to, the oil that congeals means it has a lot of unsaturated fatty components. What we do most times is to allow it to come to room temperature and see how much of it that can be recovered. But of course, you are looking at time too, the rush hour thing. But to your question, yes, you took a good decision. On the other hand, economically, well, it's okay. it's fine. It's really, really fine. No problem, sir. You took a good decision, yes.
Thank you, sir.
You're welcome, sir. Any other concern?
Yes, gosh, my hand is up.
Okay, go ahead.
Hello, good morning, sir.
Good morning.
All right. Thank you thus far. I have a question.
Okay.
Now, about the fluorine component in the toothpaste, and I want to ask. Now, there's a toothpaste with a component activated charcoal. Would that be a substitute? That's question number one. And then question number two, let me talk about the growing waste decompositions in the FCT. Now, I actually took some walk down to the furniture industrial sites around the suburb of the FCT, which is actually close to the city center. That's the Kubo furniture market. Now, what I actually observed there, part of the market in which glass is being produced for the onward transmission for furniture. Now they get to every section of that place, you have this glass on the ground, like what they use for the mirror. Now, how do they dispose of it? Because it's a growing concern. If you're going into the market because they have a section for it, they just dump it there, and then when it's rain, and then it's washed down there. So how properly can those glass or mirror equipment be dumped, or how can it be taken care of for the sake of the environment? Because for me, it has been a growing concern in TOSFA. So that's where I am coming from. Thank you.
Thank you very much. First of all, I was expecting to hear about the sawdusts. I was also expecting to hear about the filings, the dusty environment, then before this one. For the glass primarily is silicon dioxide, which is the same thing as the earth we match. But the component that is dangerous is the glazing that gives it a reflective property, which is done using metals. For the very high quality glasses, they use silver, and which is expensive. The other ones, they use glazes, which are dangerous. Now, the most appropriate thing to do is to have a specialized dump site. And that dump site should be constructed in such a way that it is not an open, fully open dump site. It's like a controlled dump site where these glasses can be recycled from. You move them from there to a recycling plant. And that is the next thing that should be done, setting up a mini recycling plant that can receive some of these glasses and recycle them into new glass materials. That is possible. That is the best way to contain that menace. But for now, looking at the country where we live in, such facilities may not, and no, of course, they are not in place. But going forward, if the government or individuals who are interested wants to do, it's to set up a recycling unit for this glass. And collection should be controlled and well coordinated. So, my dear, for now, I don't think anything can be done except, one, establishing a controlled collection point or dumping site, and bringing up a recycling unit, because you can easily recycle glass, both the bottles, the mirrors, the whichever type of grade, you can recycle them back to useful products. So recycling is the best way to go. First of all, well coordinated gathering or dumping system or disposal system, as the case may be, and a recycling unit. These are the two options left for us to implement, available for us to implement. So I don't know whether that answers to your concern. Hello? Hello? Are you there? Hello? Hello?
I guess it answers to our concerns, sir.
Okay. So any other, listen, before we wrap it up this morning? Hello?
Let me unmute every other person, and if you want to speak. Okay, Dr. Esen, you can unmute yourself, sir. Dauda Mordecai.
Yes. Good morning, sir. Good morning, everybody.
Good morning.
Yes, I have concern on this particular topic, and it's quite interesting. I happen to live around Champion Brewers. It's actually located in my community, and they have a excavation behind the company where they channel their effluents, all their wastewater into. And that place is a vast portion of land where the community women plant pumpkin and water leaf. And those women now see this water as a source of water for their pumpkin and water leaf. I want to ask, is there any side effect? Because I know those water, they are elements of chemicals, and they scoop the water and pour on the water leaf and the pumpkin. I don't know, they cut it, go to the market and sell. Is there any side effect?
Yes, there are, and that is what we have been talking about. Definitely, those plants, during their uptake for minerals and nutrients, take up part of the chemicals. The chemicals I don't know, because you did not describe what the sources and the material inflow. But definitely, for the fact that there are reagents or chemicals being discharged there, yes, these plants take them up and, like I said before, store them in different parts of their body, either the flowers, the leaves, the seeds, the fruits, all parts of the body. So, yes, there are, but the amounts are usually minute and may not cause an immediate health challenge, but they have accumulated effects. They give this accumulated effect after a while. That is why some people, depending on their system, if they don't have a mechanism, if their body system are not efficient, are good enough in ingesting this thing from the liver or the kidney, as the case may be, develop health issues, challenges much later in life. You see them at 30, 40, 50, having challenges due to consumptions that were made several years ago. Yes, there are. I must confess, but what can we do? Such a site should have gone through a treatment unit before being finally discharged into the environment. That is what we propose at every time. I want to quickly mention here, I saw a chart by one of us, I think Ruben. Ruben said, medically, the fluoride component of toothpaste has been described to strengthen teeth and so vital for dental health. I agree with you, Ruben. Fluoride is apart from strengthening the enamel of the teeth, it also has antibacterial, antimicrobial potentials, which also protects our teeth. However, the nature of fluorine, when it gets into the system, also establishes it as a potential chelating material that can react very ferociously and cause cell lysation. So the issue is not about the fluoride content. The issue here is about the quantity that gets into us. Most companies, because of competition, have this as basically a composite component of their toothpaste. And we keep ingesting, we keep swallowing some of these things unconsciously, not knowing what the final implication would be. We are not in doubt of its good sides, but we are questioning the eventual accumulated impact. That is the challenge. Not that it's not a totally bad thing. It's not. It's something that we need, but what quantity and for how long? That is why it's now of great concern. Thank you for that pointer. Any other concern? Okay, yeah, I'm reading. Okay, Miss George, the charcoal, yes, the charcoal is very good. Charcoal is a very good whitener and absorbent. However, shockingly, most companies these days don't even put the charcoal. What they put is the colorant and tell you that it's charcoal. A good charcoal, particularly from sources like bamboo and the rest of them, you discover are meant to whiten, absorb bacteria, and keep our dental this thing very healthy. But the question is it the right charcoal? And is there charcoal at all in it? Some of them don't have charcoal. Anyone, for example, those ones that they sell for 500, these small travel pack size, the truth is that they don't have the charcoal we are talking about. Because the real charcoal that we are talking about, we are preaching about, it needs to be activated, goes through a process before they can be of use. Ask yourself now, in the local market, a kg of charcoal, the one we use in cooking, costs how much? And it's in a very high demand as we speak. But people claim they produce this toothpaste using the same charcoal. You buy the same charcoal, you activate them thermally before you include them into the toothpaste. So the point is, charcoal is good, but is it the correct charcoal that is being used? And is their charcoal truly in these compositions? But if you have the original thing, the good one, it is wonderful. It is wonderful. If you have the good one, it is good. It is healthy. It is the best. Thank you for that pointer. Any other concern?
Prof, please, I want to
Yes, please.
add.
Yes.
Concerning this fluoride in toothpaste, no, like
Yes.
me, I'm using Colgate. It's written on it charcoal, but if you look at the composition, the fluoride is still there. They still mention that fluoride toothpaste. So the whole thing is even
Yes.
confusing.
No, don't get confused. Look at the amount of fluoride across these toothpaste brands.
Okay,
The
sir.
amount of fluoride across these toothpaste brand. That is why some companies are going towards herbal. What the fluorine or the fluoride component does in some is what they use herbs like mint, peppermint, and the rest of them to substitute. You understand what I'm saying?
Okay.
Yes. But the
Yes, sir.
fluoride is important, is healthy when taken in very small doses. But the cumulative
Okay.
effect is what we are talking about. So where it is possible,
Okay.
the charcoal, grind your own charcoal and add to any normal toothpaste. It serves a good purpose. Grind your charcoal very well if you have that kind
Okay.
of time. If you have that kind of time, grind it very well to very fine powder and use it. Just, okay, do this experiment. This is a weekend. Grind your charcoal today. Grind it to fine powder. Buy any toothpaste, just small toothpaste. This is an experiment. Use it. Just take the toothpaste and add a little of the charcoal you've ground. Use it morning and evening for this weekend. That's 3 days. Watch your dentition by Monday.
Okay.
Yes, you will see the difference.
Okay. Thank you, sir.
You're welcome. Any other concern? VO, Victoria, I hope you have the original bamboo charcoal. I'm interested. How much is it? Victoria, she's not responding. Someone is asking for how much of the fluorine we are looking at. You go for a 0.001%. That is safe. Brown, Miss Peace, a 0.001% is healthy. Okay, your bamboo charcoal is how much? Sorry, I'm going through the charts to see what people are doing. You simply grind. Tewa says asking how we can prepare the charcoal. You simply grind the normal charcoal you have around you and heat it up without burning. No, heat it up to temperatures of up to 100 or 105 degrees for a while. You have your activated charcoal, which you can use alongside your normal toothpaste. Okay. Mordecai is saying the rice mill located close to River Benue in Makurdi plays an important role in food production and job creation. Yet, they release black smoke, yes, from burning processes and engine activities that affect air quality. How can we realistically reduce this pollution and protect the health of workers, nearby residents, and the environment without stopping the mill's operation? All we need to do is bring in a mill that operates on a clean energy system. What they do is open burning or open cooking. But if we have a pyrolysis unit, which will be expensive, that's why people don't go to that part. There are mills, rice mills, that don't operate on such open systems where you have burner systems and all that. So you can recover the black oil. The black oil is even useful as an additive in agriculture. So if you can modify the mills and the activities, we'll get to that point. No, don't reduce brushing. Miss Peace, don't reduce your brushing. Rather, be careful with what you brush with. we ought to brush twice a day. At least twice a day. Instead of twice, no, we brush twice a day, morning and at night. Morning at night. Like I said, you can try to select, if you have that ability to select the toothpaste, you can mix it with the normal natural charcoal for your brushing. Don't reduce it. The number of brushings, yeah. Miss Comfort, I greet you. Taylor, thank you very much. I appreciate you. Terry. Can we do this? Terry, you are asking about climate change indicator with various parameters. How do we track the carbon emissions? Yeah, we will do that. We'll have 1 more hour to tidy up this class. So I think we should be able to do that. We'll have 1 more hour to tidy up this class. So we can do that during the last hour of this class.
Okay, sir. Thank you very much, sir.
Yeah, just remind me. We'll talk about it briefly in the next class. You have interesting charts here. I'm enjoying your charts.
Yes,
they are
sir.
really good. Yes. Mr. Sheung. Yeah, the government, if our government is people-oriented, they can establish these clusters of mills, modern mills for people. They don't need to drive those people away. They can establish them, and then they pay stipends to use them at times, when they want to. Because these people are not rich enough. They are not strong enough to establish these modern day mills. But the government can do that and collect revenues from its use from these people, That's a very good idea. But you see, except some of you who are close to the corridors of power, I am only a teacher, a humble teacher teaching. I don't have the power to influence government, but you people can influence government, looking at where you're all coming from. Since these ideas have been, projected here, and that's why I said that this training, this master class, is not just for theory and certificate. It is to equip you guys, to know exactly what to do when you go back to your offices or, parastatals, as the case may be. Because I know many of you are from different parastatals, offices, and corridors of influence. So these things are, for sure, they are real. Can we do them? Yes, we can. Do we have the expertise? Yes, we have the expertise. I think I have demonstrated that these things can be done. You also have demonstrated you have the capacity to project this by these case studies you have undertaken. For you to have, partaken in this case studies shows that you have the ability to articulate these ideas. You have the ability to know where the problem is coming from. You have the ability to know what this problem is all about. You have the ability to ascertain the magnitude of the problem. And you also have the ability to mitigate, profile solutions to some of these things. So it's all about will, political and economic will to do this thing. And our environment will become safe. I am also happy with what I'm reading on this chart. It's really good. So for now, I want us to take a break and reconvene by 1 p.m. to round up this class. So thank you very much, and
Thank you, Prof.
see you by 1.
Thank you very much, Prof.
You're welcome,
Please,
sir.
thank you, sir. Some person said they have not joined the group. I just dropped the group link, in the WhatsApp chat box. Please do well to join the student group so that you can be added to a group. And we intend to share a Google form that will be used to get all our details per group and attach our names to all our group assignments.
Yes, it's very important, please.
Yes, all the groups you belong to, we'll share a Google form that we will now use to collect all our names, application number, as it is for now.
Yes, yes.
And attach it to the group assignment and so on.
Yeah. Thank you very much. And I didn't hear Mr. Tezungwe. Tedius, you didn't say anything.